All right, so here is the next section. Here's chapter 2. I'm going to start off with a review of last class, just to remind you what this looks like. So if I'm asking you to sketch a graph using a vertex, I need to get the equation into vertex form. So if you recall with this, I'm going to take my equation, I'm going to split it, f to the x to the power of 1, and I'm going to divide this by 2. And that's going to tell me what my perfect square is. So if I divide this by 2, I will get x minus 1 squared. And if I expand this and multiply it all out, I'd get x squared minus 2x plus 1. So I'm going to add 1 onto this side of my equation and subtract it from the other, since I can't change my equation. So I get y equals x squared minus 2x plus 1 minus 3 minus 1. So this side now is my perfect square, x minus 1 squared, and on this side, minus 4. So this gives me the vertex of positive 1, negative 4. So this we can plot out. There's my vertex is at 1, negative 1, 2, 3, 4. There's my point. X squared is positive, so it needs to open up. So I go from this point, I go out 1, up 1, out 1, up 1, 2, 3, out 1, up 1, 2, 3, 4, 5. Same on the other side. 1, 1, 1, 3, 1, 5. And then connect the dots. So that is what you learned in chapter 1 to be able to do this. Now what happens if there's something in front of the x squared? If you remember in the factoring unit, putting something in front of the x squared messes things up. And it does the same thing with quadratics. It does mess things up again. But it's not as bad as what you think. So first of all, it messes with how we complete the squares. So I can't complete the square if there's a negative there. I'm still going to split this equation into, well, it's not really half, but split it up. But before I'm going to divide this term by 2, I need to divide or factor out whatever's in front of the x squared. So I'll have y equals negative, and then in brackets, x squared plus 4x. So I factored out the negative from here. Whatever's in front of the squared term, you factor it out, no matter what it is. So now I'm going to take what's inside the brackets and make that into a perfect square. So if you remember, I take this term, divide it by 2, so I need x plus 2 squared. Multiply this out, you get x squared plus 4x plus 4. So inside the brackets, I'm going to expand that out. So we get negative x squared plus 4x plus 4. And then I need to cancel that out on the other side. Now, careful. What did I do on the left-hand side of this expression? I added 4 here, but because there's a minus here, when these two correlate with each other, they don't give you a positive 4 on that side, they give you a minus 4. So if I correlate the two of these, I really subtracted 4 from this side of the equation. So instead of subtracting 4 here, I need to add 4. So this is just the part of the reason why this makes it a little bit trickier. So I added 4 here. Again, I need to correlate what's on the outside, times it by what's on the inside, and then figure out what I actually did on this side of the equation, and then cancel that out on the other side. Now what I have in the brackets is a perfect square. So minus x plus 2 squared. Combine the other side, we get plus 6. So here is our new perfect square. So the vertex is minus 2, again, opposite of what's in here, positive 6. So we can plot out that point. Here's negative 1, 2, positive 1, 2, 3, 4, 5, 6. So here's my vertex. Now, because there's a negative in front of the x squared, instead of going out 1, up 1, I go out 1, down 1. So it'll look out 1, down 1. Out 1, down 1, 2, 3. Out 1, down 1, 2, 3, 4, 5. And then it would be 7, and then 9, and then 11. But you don't need to do that many. So out 1, down 1, out 1, down 3, out 1, down 5. And here is my parabola. And don't forget the arrows. So that is the trick with this, is you need to first factor this out and then solve. So let's try something that's not just a negative. The negative just means it opens down. What if there's a 2 here? Well, the nice thing is they've already given us the vertex, so we can actually make that first. So the vertex of this one is just positive 3, negative 4. So plot that out. 1, 2, 3, 1, 2, 3, 4. So there's my point. But this 2 affects how I do the next points. So instead of going out 1, up 1, out 1, up 3, I'm going to change that pattern. So here's the typical pattern. So here's the vertex. Out 1, up 1. Out 1, up 3. Make that a little bit longer. Out 1, up 5. And so on and so forth. Same thing on the other side. Go up 1, go up 3, go up 5. Now what this A value is, or this outside value, it's going to affect how much I go up. So this 2, I'm going to take all my ups and times them by 2. So now I'm going to go up by 2, up by 6, up by 10. So this is how this is going to change my graph. So whatever value is here, I times that by 1, by 3, by 5 to get the new increments I increase by. So with this, applying it to our graph, I go out 1, up 2. Out 1, up 1, 2, 3, 4, 5, 6. So I'm doubling the amount that I go up. Same thing, left 1, up 2. Left 1, up 6. And then connect the dots, put arrows. So that's how this changes things. You just readjust that. So for example, this one, it's minus 3, so I'm not actually going to plot this out, but taking your vertex form, instead of going down 1, down 3, down 5, you're now going to times each of these by 3. So you'll go down by 3, then down by 9, then down by 15. So that just changes what your vertex is going to look like, or changes how you're going to adjust from the vertex. So now let's look at how to make a perfect square from an equation like this, and how to then plot that. I'm just going to show one example, again for the sake of time, but if you need to see more in class, come and talk to me. So here's our equation. We split it up, and we first need to factor what is going on here. So by factoring it, we end up with y equals 3. I need to factor out what's in front of the x squared. That gives me x squared minus 4x, and then plus 7 here. Again, minus 4x because I'm taking 12, dividing it by 3. Turn this into a perfect square. So to do that, x minus 2, because I took this and divided it by 2, which if we expand that out, x squared minus 4x plus 4. So inside the brackets, I need to add 4. So we get 3 x squared minus 4x plus 4, and plus 7 doesn't change, but I need to see what I did on the left-hand side. So when I did this, I added 4, but it's also times 3. So really what I did is I added 12 onto this side of the equation. So I need to subtract 12 from this side of the equation. So now the bracket is a perfect square. So I've got 3x minus 2 squared, and then 7 minus 12 gives me minus 5. So let's find the vertex of this. So my vertex is positive 2, negative 5. I can plot that. 1, 2, 1, 2, 3, 4, 5. There's my vertex. And again, my value in front of x squared here is a 3, and it's positive. So I start at my vertex, go out 1, up first by 3, out 1, up by 3 times 3, which is 9, and then go up by 15. So that's our pattern. So we can look at our point. Out 1, up 1, 2, 3. Out 1, up 1, 2, 3, 4, 5, 6, 7, 8, 9. Just goes one above the graph there. So again, left 1, up 3, left 1, up 9. And there's my graph. As long as your points are correct, I'm not going to mark the drawing super harshly with that, but there you go. All right, I am going to leave it at that. Again, this is just showing one example of each of these. I'm not expecting it to sink in at that point, but I don't want to make the video super long. So come to class if this doesn't make sense, and I can explain any examples that you need to with that.